This video will give examples from our brief introduction to calculus. Draw a tangent line at x equals 4 and draw a secant line through x equals 3 and 5. So I'll start with my secant line. Here's x equals 3 and here's x equals 5. So my secant line will just go through these 2 points. And then for my tangent line, here's x equals 4. So it just barely touches at this point. Find the slope of the secant line. So this is just our simple algebra. All we have to do is y2 minus y1 over x2 minus x1. So 3 minus 0 over 2 minus 0. So our slope is equal to 3/2. Use secant lines to approximate the slope of the tangent line. So at our point -1, -1, we've got a tangent line that looks something like this. And our graph is the curve y equals x cubed. Let's make a table of points to see what we can do here. So we'll have point 1, x1, y1, and then x2, y2, and slope. Okay, so we can start out by choosing points that are pretty far away from -1, -1. So let's say that we choose -2 and 0, 0. So if we plug in -2, we'll get -8 for y, then 0, 0, and this would give us a slope of 4. What if we move our points in a bit closer? So let's try -1.5 and -0.5. This gives us 3.375 negative and -0.125 here, giving us an overall slope of 3.25. Now let's move in even closer. How about -1.1 and -0.9? Then if we plug these numbers in, we'll get 1.331 and 0.729, both of these negative. And for our slope, we would end up with 3.01. Okay, let's bring it in one last time, extremely close. So how about -1.001 and -0.999. Now these two are pretty much the same thing as 1 by now. So if we plug these in, for y, we'll get 1.003, just about, and -0.997. So if we want to find the slope between these points, we end up with a 3.00001. So if we were to guess the slope of the tangent line at -1, -1, 3 would be a pretty good choice. Approximate the length of the curve y equals x squared from x equals 0 to x equals 3. So I'll draw out this curve first. Okay, so here's 0, 1, 2, and 3. We can approximate this curve by marking it into lines. Okay, so we have the point 0, 0, 1, 1, 2, 4, and 3, 9. Let's find the length of our first line from 0, 0 to 1, 1. We can just use the distance formula d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we plug that into our formula, we find that d equals the square root of 2. Now we can do the same thing with our second segment of curve, and so here we'll find that d equals the square root of 10, and we can find the length of our last segment here. We get d equals the square root of 26. So if we add up these three distances that we found, then we can get an approximation for the length of the curve. D is about 9.675. Later, we'll be able to use the tools of calculus to divide our curve into an infinite number of lines and find the exact length of the curve.